So when we're talking about aqueous solutions, we have to talk about a unit, or what we call a unit of concentration, to describe, if a solution is what we call concentrated or dilute. And so the most common unit of this expression we use is molarity. And so whenever you see molarity, it's a unit of concentration. It tells you how much solute is in solution. So if you remember, or maybe it might not be fresh in memory, but a solution is made up of a solute and a solvent. And the solute is the smaller amount, the solvent is the greater amount. For example, you put sodium chloride in water. Sodium chloride is a solute, water is the solvent. And so we use molarity to describe, how much solute is in a solution. So if there was a lot of solute, we would say it's a concentrated solution. If there is very little solute, we call it a dilute solution. And the way we find molarity, which is capital M, that's the symbol for molarity, is taking the moles of solute divided by the liters of solution. So again, your solute has to be in moles, your solution has to be in liters, because the units for molarity are moles per liter. And so if we wanted to describe the concentration of, say, sodium ions, typically what you do is you put it in brackets, and this is understood that when you say the sodium ions equal, for example, 0.01 molar, you know that you're talking about concentration. And this is a very powerful unit to deal with because it gives us an idea of the amount of solute in the solution. Again, the common errors is students forget to convert the solution to liters if it's given in milliliters, because remember, it's moles of solute over liters of solution. So here, for example, we want to calculate the molarity of a solution prepared by dissolving 15.6 grams of KBr in enough water to make 1.25 liters. So remember, molarity is moles of solute over liters of solution. If you just simply took the grams and divided it by the liters, you would get a unit of density, which is not what we want. So the first step would be to convert the mass to moles by dividing by the molar mass. So anytime you're given mass and volume and it asks what's the molarity, you always need to divide by the molar mass to get the moles. Once you have the moles, make sure that your volume's in liters, and then you can find the molarity. And so the way you would read this is 0.105 molar, like in the back of your teeth, the molar teeth. You would refer to this as a 0.105 molar solution of potassium bromide. We want to know calculate the molarity of a solution prepared by dissolving 2.80 grams of sodium chloride in enough water to make 135 milliliters of solution. So again, you don't just simply take the mass and divide it by volume. That would give you density. But again, the first step is to convert the mass into moles by dividing by the molar mass. The second step, we take the moles and divide it by the volume in liters. So notice here that I converted the volume from milliliters to liters. And so this would be a 0.355 molar solution. And so what you can do is by looking at both these numbers, you can say that the solution in the first example is less concentrated than the solution in the second example because this molarity is less. Oops. So again, we're going to be using molarity to help us when we're dealing with stoichiometry, where we're not given mass of a reactant, for example, we're giving the volume and concentration of a reactant and ask how much product is produced. And that's going to be what we do in solution stoichiometry. So we're going to have to use this equation to take volume of solution and concentration to find the moles of solute so that we can use it in the chemical equation to solve for example the amount of product produced.